So again, we have this word simplify. This one does not ask us to define it. So part of the question here, they define it for us in this part. That's the definition for the variables, where it works and where it doesn't work. But that's not actually part of the question. We just need to simplify this part here, this part up to here, and this part up to there. So we remember that for simplifying radicals, we want to write them as mixed radicals. That's the first thing we're going to check. Then we're going to put our like radicals together. So in A, when looking through A, root m, root n, those are already as simple as they'll get as far as mixed radicals go. Now we just have to put like terms together. We have 7 root m's minus 3 root m's will give us 4 root m's. And 2 root n's plus 5 root n's will give us 7 root n's. So the first one, again, relatively easy because things were already written as mixed radicals. For B, we have, again, they're already, if we look inside, we've got the square root of negative 3b and the cube root of negative 3b. But there's nothing you can pull out as far as the numbers go, and there's nothing you can pull out as far as the variables go. So all of these are already written as mixed radicals. But as far as like terms go, the cube roots have to go together with the cube roots, and the square roots will have to go together with the square roots. So if I have 2 cube roots of negative 3b minus 9 cube roots of negative 3b, I'll be left with negative 7 cube roots of negative 3b. And if I have 8 square roots of negative 3b plus 3, that'll give me 11 square roots of negative 3b. Yes? It's okay to have negative here because it's been defined. As far as where it's defined, b has to be negative. And if b is negative, times by another negative will be positive inside. And then for part C, here inside of our square roots, we have things that can be simplified. 32, although 32 is 4 times 8, it's also 16 times 2. If you can see the largest perfect square inside, that's going to help you simplify it quicker. If you chose 4 and 8, when you simplify it first and you're left with square root of 8, 8 can be simplified again because it's still 4 times 2. 45 is 9 times 5, b cubed plus 5b. 125 is 25 times 5b minus 2a. 72 is 9 times 8, but 72 is also 36 times 2. And 36 is a bigger square root. So first of all, I just rewrote each of them with the biggest square root that multiplies, because now I can pull this out. Square root of 16 is 4. There's already a 3 in front. 4 times 3 is 12. Now, as far as our variables go, because it's a square root, you would need 2 of that variable. A squared, the square root of a squared becomes a. So if I have 5 a's inside, can you see that that would be 2 pairs and 1 extra? Can't see that on the video. Too bad. So I can pull out 2 a's, and I would still have 1 a left inside, and I still have a 2 left inside as well. Okay, are you okay with this going from here to here? Because the square root of 16 is 4, And when that 4 comes out in front and hits that 3, 4 times 3 becomes 12. Okay? Minus. Here, the square root of 9 is 3. 3 times 2 will be 6. And I've got a b cubed, which means 3 b's. Well, it's hard. Then 2 of them, 1 could come out in front. And then you're just left with 1, which carefully I chose that finger. Okay? And we still have a 5 and a b inside. Here, square root of 25 is 5. That 5 hits this other 5 will become 25. We have a b. There's only one b inside, so there's nothing you can do with the variables in that one. And finally, the 6 would come out. 2 times 6 is 12. We have a cubed, which means we could pull out 1a. The 1a that comes out hits this other a, which would give us a squared in front, and we still have 2a inside. Notice now we have some like terms. 12a squared 2a minus 12a squared 2a. Those will just go away because they'll end up with 0. And we have negative 6b root 5b plus 25b root 5b will give us 19b root 5b. And that is simplified. So last questions to work on. Number 8.